Welcome to our very last section on trigonometry, and in this section I'm going to review some information about special triangles that we always run into in trigonometry and are used as standard references whenever we're dealing with trigonometric ratios. And the first of these ratios that we're going to talk about is the 6 trigonometric ratios of the angles 60 degrees. Well, in order to understand where this comes from, this is where we're going to use as a memorization tool the fact that we know that an equilateral triangle is a triangle where all sides are the same and therefore all angles are the same. We know that in any triangle, whether it's right or equilateral or otherwise, the sum of the angles is always 180 degrees. And of course, if all the angles are equal, then all the angles will be 1/3 of that, which is 60 degrees. So let's pretend that we have a equilateral triangle where all 3 sides have a length of 2 and all angles are 60 degrees. How can we use this to our advantage? Well, let's take a look. If we know that each of the lengths of the sides are 2, then let's take our triangle and divide it up. We're going to take our triangle and 2 of these sides right here, and let's just chop the whole thing in half. Right, so let's take this triangle and let's just take this piece right over here and just move it away. What do we know about what we have left? Well, first of all, we know that we have a triangle where the hypotenuse is 2. But since we chopped it in half right here, we know that the bottom piece of this right triangle has a length of 1. And again, you remember that by our Pythagorean theorem, we can find the length of this third side fairly easily by using our Pythagorean theorem, where the square of side A plus the square of side B plus the square of side C is equal to the square of side C. And so we know that we have 1 squared added to our unknown side B squared is equal to our opposite side 2 squared. So 1 plus the square of B will equal 4. And subtracting 1 from both sides gives us B squared is equal to 3. Therefore, the length of that opposite side will be the square root of 3. Every single triangle that contains a 60-degree angle in it will have the ratios equal to the sides that we get from this triangle. So if we say we want to find the sine of 60 degrees, the sine of 60 degrees will be equal to the ratio opposite divided by hypotenuse, square root of 3 over 2. For 60 degrees, the cosine is the ratio of the adjacent side to the hypotenuse side. And we know that in this particular case, that means a ratio of 1 to 2. It's 1/2. The tangent of the angle theta, in this case, our angle theta is 60 degrees, so the tangent of that angle, 60 degrees, is equal to the ratio of the opposite side to the adjacent side, which in this case is square root of 3 over 1, or simply square root of 3. Our cosecant of 60 degrees is going to be the ratio of the hypotenuse to the adjacent side, so we could write 2 over the square root of 3 for that here. For secant, we're going to take the ratio of the hypotenuse to the adjacent side, which is the reciprocal of cosine. That's 2 over 1, and we simply write 2. For the cotangent of that 60-degree angle, of course, we take the adjacent side divided by the opposite side, so that'll be 1 over square root of 3 in this case. All right, well, that seems like a ball of laughs. Let's try the next one right here. What about 30 degrees. Well, 30 degrees is in fact exactly the same problem that we had before when we were dealing with our trigonometric ratios for 60 degrees. In this case, let me see if I can get my board to work with me here. If we just simply take away our equilateral triangle, which I've now turned on its side, and look at the different sides, well, this is one that we've already dealt with. In fact, we know that the lengths of our sides are easily found right here because we, again, chop this in half, and as we solved in the last problem, made this the square root of 3. So what does that mean? Well, for the sine of 30 degrees, we're going to get a ratio of opposite to hypotenuse 1/2 in this case. For the cosine of 30 degrees, we're going to get the ratio of adjacent to hypotenuse, which is square root of 3 over 2 this time. And for the tangent of 30 degrees, we're going to get the ratio of opposite to adjacent, which is 1 over the square root of 3. Continuing on then, the cosecant of 30 degrees is our ratio of hypotenuse to opposite, which is 2. The secant of our angle 30 degrees is our ratio of hypotenuse to adjacent, so that's going to be 2 over the square root of 3. And our cotangent of 30 degrees is going to be our ratio of adjacent to hypotenuse, and that'll be square root of 3 over 1, or simply square root of 3. And so dealing with these ratios right here is the same as we've dealt with before. If you check out our 60-degree angle, you'll notice that all those values look really, really familiar. One more special triangle that you'll want to know is the 45-degree angle. And to picture a 45-degree angle, picture a square that we slice along the diagonal. When we do so, the lengths of our sides right here, oops, come on now. Let's get that selector working here. When we take away the square that we get from that and divide it in half, well, we see a very nice right triangle that we can deal with here. And we know two of the sides. We know our two adjacent sides. What's the length of that diagonal? Well, dealing with our Pythagorean theorem, we take the square of one leg plus the square of the other equal the square of our hypotenuse, which is to say 1 plus 1 is equal to 2. And so our hypotenuse is the square root of 2. So how do we use that? Well, the sine of the angle, 45 degrees, is going to be 1 over the square root of 2. The cosine of the angle will be exactly the same since the adjacent and the opposite side equal each other, so it's 1 over the square root of 2. And the tangent of the angle 45 degrees is the opposite over adjacent side, which is 1 over 1, or simply 1. For cosecant of 45 degrees, our angle is the hypotenuse over the opposite side. Well, that's just square root of 2 over 1, or simply square root of 2. For secant, we take the adjacent under the hypotenuse, so hypotenuse over adjacent, square root of 2 again. And for cotangent, we take the adjacent over the opposite. Since both of those are equal to each other, our ratio is 1. These are the ratios of our three most common angles: 30 degrees, 45 degrees, and 60 degrees, and it's recommended that you spend some time memorizing these in order to help you. Good luck with your assignment. I look forward to seeing you in class.